This is the first video in a three-part series on section 4.1 on maximum and minimum values. So in this first part, we're going to be talking about absolute maximum and minimum values. Generally, when we talk about maxima and minima, so maxima is the plural of the word maximum and minima is the plural of the word minimum, we're just talking about high points and low points on a curve. So if, for example, we had this hiker walking up and down on a mountain trail, then we could represent the height of the hiker, the altitude of the hiker, as the y-axis, and their horizontal distance as the x-axis. And when that hiker reaches the top of a hill, they've reached a high point. When they reach the bottom of a valley, they've reached a low point. So that's all we're talking about. So as you watch the rest of this video and the other videos in this sequence, just keep that in mind that we're just looking at high points and low points on our graph. So specifically, we could talk about the highest point on our graph, and we call that the absolute maximum. And the y value at that point is called the absolute maximum value. In other words, the highest y value the function ever achieves. And the lowest point on the entire graph would be called the absolute minimum. That's the absolute minimum y value that the function ever actually achieves. So on this graph, it looks like our absolute maximum value might be somewhere around there for our absolute maximum. And our absolute minimum looks like it might be right around there, the lowest point that this graph ever achieves. It's a little hard to tell. It looks like it might be that the graph goes a little bit lower over here. We're not sure, so we're just using our best judgment on that. Okay, let's do a couple of examples. So we've got a function here, and we want to identify the absolute maximum and the absolute minimum points on this graph, if this function even has any. And we're going to talk about when a function does or does not have absolute maximum and minimums a little bit later. So on this graph, again, what I'm asking for here is relatively simple. I'm just saying, where on this graph does my function achieve its highest y value? And so hopefully we can see without too much trouble that this point here is going to be an absolute maximum. And which x value does that happen at? It happens at x equals b. And then if we look for the lowest point on this graph, what we will see is that that's going to happen here. So there is going to be my absolute minimum. That's the lowest y value I get. And where does that happen? That's going to happen at x equals c2. So that's it. That's all we're looking for. But sometimes it's not quite that easy. Sometimes it's a little bit more complicated. So let's look at this example. So here we've got a little bit more complicated function. It's got some filled in dots and some open dots. We'll talk about how we're going to deal with that. But the easier question to answer here is absolute minimum. Certainly this function never gets lower than it does at x equals a. So there's an absolute minimum at x equals a. But what about a maximum? It looks like the function gets as high as it ever gets here near x equals c. But something a little bit weird is happening at c. Because of that open circle, it looks like the y value is getting closer and closer and closer, but the function never actually reaches this point. As we've seen, when we have those open circles, that point is actually missing from the graph. So the function value is getting higher and higher and higher, and as we zoom in on that point, the function value creeps up a little bit and a little bit, a little bit, but it never actually quite gets to that point. And so if we zoom in further, we could get a little bit closer to that point. If we zoom in a little bit further, we could get a little bit closer. But we never actually hit that maximum value, and so this function has no absolute maximum value. Think of it like if I wrote down the list of numbers 0.9, 0.99, 0.999, 0.999, and so on. That number, that list, doesn't have a largest number on it, because if I want to go a little bit larger, I just go a little bit further down the list. So I don't have any maximum value on this list. So it's the same basic idea. So just in summary, to kind of sum up, the highest point on a graph is called the absolute maximum, and the y value at that point is called the absolute maximum value. Similarly, the lowest point on a graph is called the absolute minimum. The y value at that point is called the absolute minimum value. And a given function might not actually have an absolute maximum or absolute minimum value. And so what we're going to talk about a little bit later is under what conditions does a function or is a function guaranteed to have that absolute maximum or absolute minimum value. So I'll see you soon in part 2.